Next, we have a very interesting topic based on this. So I said you there are two types of charging methods, right? One is charging by friction and another one is charging by induction. Okay, what is it? One is charging by friction and another one is charging by induction. So friction we have seen, whenever two bodies or two materials are rubbed with each other, they get charged, right? As they get charged, as one is giving out the charge, it becomes positively charged. As another one is receiving the charge, it becomes negatively charged. Similarly, here we have another type of method which we call it as charging by induction. So charging by induction is a process where you whenever a body is completely charged, for example, if this is a ball, this is completely charged. Now what I have to do is I have to add charges to it, but that shouldn't lose any type of charges. Clear? Now I have to add charges to this. So if I add charges to this ball shouldn't lose charges. So this type of method we call it as induction. That is, whenever you want to give charges or whenever extra charges are given, the prior charges whatever were there in that material will be the same. It won't change. It doesn't lose. Okay, it doesn't lose charges, but it remains the same. So that method we call it as charging by induction method. So here first thing, experiment will go, which is very interesting, and I hope you will enjoy this. Because coming to the first thing, what I'll do, I'll take two spheres, metallic spheres. Metal means what? Conductor. Conductor means what? Free electrons, right? Free electrons means they are free to move. So I'll take two images here, that is two spheres. So as I take two spheres, these are uncharged. These are not charged. Okay. Next, in the second case, what I'll do, I'll get a rod which is of ebonite, you can say. I'll get a rod which is of positively charged. Positively charged rod. Positively charged rod. I'll bring it near the sphere. So once I bring it near the sphere, what is happening? This sphere, it is uncharged, but as I bring positive charges, as unlike charges attract, what happens? The negative charges come here at this end. What happens? This will be negatively charged here. Why? Because unlike charges attract each other. So as one side completely the negative charge comes, what happens to the other? Here you get positive. Why do I get positive here? Because repulsion will happen. Positive repels, positive negative attracts. So this is what we are doing here. Next, what I'll do is I'll take this charge rod and also the sphere which is charged, and I'll bring it back. So as I bring it back, what is happening? Here, this setup, I'll bring it back and this will be as it is. Then after this, I'll remove this charge rod. So I'll remove this charge rod. So once I remove this charge rod, what is happening? This sphere is completely negatively charged and this sphere is completely positively charged. So this is how you charge it by the induction method when there are two spheres. Okay, I have to mention you, when there are two spheres, what is happening? In the first case, both will be uncharged. Okay, so as both will be uncharged, in the second case, what is happening? I'll bring a positively charged rod near a uncharged sphere. That time, because of positivity, what happens? The negative charges come to the outer sphere, whichever is more feasible to positively charged rod. So as it comes, negative comes near the positive because they have the attraction, you can say unlike charges attract, and the other sphere automatically becomes positive because repulsion happens and positive gets repelled. Next, in the third case, what happens? I'll just drag that rod and also sphere towards other end, and this positively charged will be at the other end. After that, slowly I'll remove this rod. So once I remove that rod, this sphere, what I can say, is negatively charged and this sphere is completely positively charged. So this is the theory of charging of two metal spheres by induction method. Clear? Next, so 2 we have seen. How to do it? Like whenever there is only one sphere, how should I do? Right? So we'll see that. So whenever we take one sphere and when we have to charge it, then we use a thing, that is a concept which is called as grounding method. So this thing I think you people know, because whenever you have a computer, gadgets or any such things like a huge appliances, all will be, we say earthing is done. What do you mean by earthing? The maximum or the extra amount of current, whatever is there, you are sending it to the ground. Why? Because it shouldn't cause any damage to the system. Clear? So this theory will be using it here in charging by induction using only one sphere. So first thing what I'll do is I'll take one sphere, okay, which is again uncharged, and it is a metal sphere. Metal sphere means what? It has free electrons. So after that I'll bring a negatively charged particle. So as I bring a negatively charged rod towards it, what happens? This becomes completely positive because unlike charges attract, right? And at the one end all the negative charges go because like charges repel, right? In the second case, what I'll do is this negative charges, whatever is there, I'll ground it. Okay. So as I ground it, obviously what I said before, that maximum charges or the charges which are extra are sent to ground because ground attracts. Okay. So a negative charges is grounded. All the negative charges go to the ground. Then what happens? You are having only the positive potential sphere. Okay, the sphere which has only positive charges, you will be getting it at the end. So here what you will see is, for the positive thing I did. Next, you have to imagine about the negative, as I don't have any picture of such, but we will do it. Okay, so first thing what I will do, this is positively I will bring. Okay, as I bring positively, what happens? Here negative charges come. As it comes negative, here what happens? Positive charges come. Clear? Next, in the second case, what happens? Because in the negative case, negative was sent to the earth. As the negative was sent to the earth, we were like, okay, this is happening. But here what is happening? Here I have negative now completely, and here I have positive. How should I use the theory of ground? What should be the theory of grounding now? The theory of grounding is nothing but this positivity, that this positive ions, from here the electrons are attracted. Okay, from the ground the electrons are attracted towards this positive potential, and that time what happens? This ionizes. Ionization happens. Ionization means positive and negative ionize together here. Okay, but here what happens? Only negative will be there, and later on, after this, after nullifying, that is after getting neutral, after getting ionized, this sphere becomes negatively charged. Clear? In the first case, the charges are moving downwards, but in the second case, if I have to make the sphere negative, the charges are coming from the ground towards the sphere so that it has to ionize. Clear? This is the main theory of charging by induction. Clear? So charging by induction using one sphere we have completed. Here, if you have any doubts, please let us know, because I am ready to explain you however you want, and like whatever queries you have, please let us know. Moving on to the next, very important, and also you can have this screenshot because this is the question they will be asking you for 2 marks, for 3 marks, right, and even sometimes for 5 marks, because unexpected, right, academics. So coming to the first, you have basic properties of electric charge. So whenever we see a man or whenever we see any human being, we say his character is good, he has good properties, like good qualities he has. Similarly, what we will be doing here is we will be judging it of the electric charge now. So what is an electric charge? We know it is a fundamental quantity which exerts force or also receives force, okay, when it is in the electrical field. Similarly, first property, where you have, there are 2 types of electric charges, namely positive and negative charges, and whenever they come together they tend to cancel out. that is they ionize, we say generally. And next one is electric charge, which is carried by a body, is not affected by its motion. Okay, so whenever an electric charge is whenever the charge is going, okay, it is not affected by its motion, like in what velocity is moving or anything. So that is not affected. Clear? Next is very important, which is like charges repel and unlike charges attract. And the next one is this electric charge has only magnitude. Okay, magnitude means what? Which has only value. Okay, but no direction. So go to your first year. What have you learned there? Where we don't have we have magnitude and not direction, then we say it as a scalar quantity. So scalar, that is electric charge, has magnitude but it doesn't have any type of direction, so we call it as a scalar. Scalar is a quantity which has magnitude but no direction. Clear? So next we have other three important properties where you will be learning about new concept, that is which you are not come across anywhere. So coming to the first, we have this property as additivity of charges. So what is additivity of charges? For example, in your class, how many members are there? Okay, I'll say just approximately there are 20 members in your class. How can you say 20? Because there are 20 persons there, right? Similarly, 20 is your total class strength, but only 15 are there. What can you say? Only 15 are there for that day, right? So what are you doing there? 20 means what? It is number of, right? Number of students in your class. Similarly, in additivity of charges, whenever I take a surface, okay, whenever I take a surface like this, okay, if there are charges here, if it is Q1 and this is Q2 and this is Q3, then how can I give the total charge? I can give the total charge by Q1 plus Q2 plus Q3 and so on till Qn. Clear? So that is, we call it as what? Additivity of charges. So if a system contains a number of point charges, the total charge of the system is the algebraic sum of all the charges present anywhere on the system. Okay, and that is known as what? Additivity of charges. Moving on to the next property, which is the conservation of charge. Conservation of charge is nothing but charge can neither be created and it can neither be destroyed, but it can be transformed from, that is, it can be transferred from one material to the other material. So that is what it is. Total charge of an isolated system remains conserved. So what do you mean by isolated system? Isolated system is nothing but it doesn't have any contact with the surrounding, or it doesn't receive anything from the surrounding. Okay, so that we call it as isolated system. Best example is whenever you have, like, whenever we go across the previous days, we had this COVID, right? So in that case, what we say? We say that COVID is nothing but it is being in an isolation. Isolation means what? No, you shouldn't be having any contact with the surrounding, or the surrounding shouldn't be having any contact with you, because it would spread easily. The virus would spread easily. Similarly, here the total charge of an isolated system is said to be conserved always, and it is constant, and that is what we call it as what? Conservation of charge. Moving on to the next, very important, that is quantization. So what is quantization? I'll tell you clearly. For example, I said there are 20 students in your class. Okay, so there are 20 boys in your class. I'll tell. What do you mean by boys? Boys is nothing but there are 20 number, that is 1, 2, 3, 4 till 20 number of boys in your class. Similarly, when I say there is a charge moving, okay, or whenever there is a charge, for example, if this is the surface and here I have a electron charge E, okay, so that surface has electron charge E.